Okay, we're going to look at writing equations for conics here. Okay, so first up we have write the equation of the circle with the given information. So number one, the center is 2, -4 with a radius of 2√3. Again, I would recommend pausing the video, trying problems on your own, restarting it when you're ready. That way, as we've said in other videos, you're getting the assessment of what you're understanding or not understanding for these concepts. If you just sit and watch the video all the way through, what you're getting is my understanding of the concept, but you aren't practicing it on your own. And so make sure you do take some time to pause the video and try it on your own, okay? So here we go, number one. Okay, so number one, again, center 2, -4, radius 2√3. So putting my center into my equation, we have x minus 2 quantity squared plus, and then y plus 4 quantity squared equals, and back here we have our radius squared, so our radius is 2√3 quantity squared, which if you wanted to write that a little bit differently, you could actually take the time to square that 2√3. So 2 squared would be 4, √3 squared would be 3, and 4 times 3 is 12. Okay. Next up, number two, we have the center is 3, 1, and then you have a point on the circle at 0, 5. Okay. So I tend to recommend graphing these. It's usually helpful for, I shouldn't say usually, it is sometimes helpful for people to see the center and the point that we're talking about, or the multiple points that we're discussing, whatever the case may be. So I tend to recommend graphing it. So we've got our 3, 1 here for my center, and 0, 5 up here for a point on my graph. Okay. And so plugging into my equation, we have our x minus our x1. Our x1 here was 3. Our y minus our y1, which was 1, equals my radius squared. Now for this one, as opposed to number one, where they literally told me what my radius was, here I'm going to have to calculate it. And so that's where Pythagorean theorem comes in. This guy here is a 3, 4, 5 triangle. And so using Pythagorean theorem, I know that that length of the hypotenuse of that right triangle is 5, and so my radius is 5. And again, you could rewrite that and actually write it as what 5 squared is if you'd like. 5 squared is 25. Okay. Number 3. Go ahead and take a look at number 3. Endpoints of the diameter are 7, 13, and -3, -11. Okay, so here we go. Again, I tend to recommend graphing. So we've got our 7, 13, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's up here. And then -3, -11. 5, 6, 7, 8, 9, 10, 11. Okay. And so here is my diameter of my circle. Okay, so first things first, we have to find our center. Now there's lots of ways of finding your center. It's the middle of this particular, or these two given points is the middle of your diameter. And so it could potentially be easy to count to the middle, between the x's and between the y's. But I would say that really only works well if you have nice numbers. Like even numbers, for example, count to the middle very easily because it's dividing by 2. But that fact right there, dividing by 2, is something we can use. It's the midpoint formula, which says I can add these two together, 7 and my -3, and divide by 2 to figure out what my x value would be. 7 minus 3 is 4, divided by 2 is 2. And I can do the same thing with the y's. My y's, adding them together, 13 plus negative 11 divided by 2 is 2 divided by 2, or 1. And so I know that my center here is at 2, 1. X minus 2 squared plus y minus 1 squared equals, and then I mat r squared. And so same thing, we've got our Pythagorean theorem here. So this guy goes over 5 and up 12, which is another Pythagorean triple, 5, 12, 13. And so I know my radius is 13, or if I rewrote that, 13 squared is 169. Okay, so let's go ahead and take a look at some of our other conics now. So we've got first up our parabolas, 2 of these. With our parabolas, we have some equations that might come of use. So with your parabola, you want to remember that you have y minus k and x minus h quantity squared. This 1 over 4c, remember c is the distance from your vertex to your focus, or your vertex to your directrix. And then the focal chord length, remember that your focal chord length is equal to 4 times c. So whatever your distance from your vertex to your focus is the c, and so your focal length, chord length would be 4 times that c. Okay? So number 4 first. Make sure you're pausing the video periodically, seeing how far you can get on your own, and then restarting it when you're ready. Okay, so number 4, we've got our focus at 4, 2. 4, 1, 2. Our directrix at y equals 4. Here's my focus, here's my directrix. And so then we need these pieces. We need our vertex, xh, and we need our c, our distance from our focus to our vertex. Okay? Well, if this is where my focus is, this is where my directrix is, where's your vertex? Your vertex should be right in between. And so in this case, my vertex is at 4, 3. Okay? And then for this to be my my parabola would have to take some sort of shape like that one. So it doesn't pass through my directrix but contains my focus. And so this is a y equals parabola, so y minus 3 and x minus 4 squared. And my a is a negative a because this parabola faces downwards. So whatever my 1 over 4c is, it's going to be negative. Okay? So then the question is, well, what's c? C is the distance between the vertex and the focus. We'll take a look here. We've got our vertex, we've got our focus. The distance is 1. 1 over 4 times 1, which is just 1 over 4, or negative 1 over 4, I should say. Okay? Okay, number 5. Focal chord endpoints are 6, negative 1, and 6, 3, with a being bigger than 0. Okay, so my focal chord endpoints, 6, negative 1, 6, 3, so 1, 2, 3, 4, 5, 6, negative 1, and 6, 3. Okay, a being greater than 0 means that this this parabola here, in order to pass through these but still have a be positive, means we've got to be something somewhat-ish like this. It's got to be rightward facing, so you pass through those focal chord endpoints. Okay, and so my focus in this particular case would be right in between, which is in this case is at 6, 1. So my focus is at 6, 1. Additionally speaking, my focal chord here across the way is a distance of 1, 2, 3, 4. So focal chord equal to 4, which means, remember, your focal chord length is 4c. that 4 equals 4c. It means that my c, if I divided this 4 over, would have to equal 1. And so I know I'm an x equals parabola, y minus, I don't know my vertex yet, and I know my c in this case is 1, and so 1 over 4c out front here, 1 over 4 times 1 is 4. So then the question is, well, what's my vertex? If this is my focus and my c is 1, my vertex would be 1 away, which would be here. My vertex is at 5, 1. And I've got my equation. Okay. Going to take a look at an ellipse and hyperbola next. Okay. So with your ellipse, you have some important information. There are kind of two equations you typically speaking use. You have your main equation that you were looking to write, right, with your center and your 2 radii. But you will sometimes need this equation. This equation would be used if you were provided foci. Remember, the c is the distance from the center to the focus. And so if you did have your foci, you might need to use this equation to solve for one of your radii, whichever one happened to be missing in that particular problem. Okay? Hyperbolas have that same attribute. Okay, so number 6. We're writing the equation of an ellipse, center at 0, 0. The length of your minor axis is 14. Your vertices are at -10 and +10. So go ahead and pause the video, give this one a shot. Okay, so we are looking at an ellipse here. So doesn't matter whether x or y comes first in an ellipse, so I'm just going to set it up as though x is first. Okay, so we've got our base equation here. My center is at 0, 0. So I'm plugging that in. And then if I were to graph the other information they've given me, I've got vertices at positive and -10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should say 0, positive and -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I've got a minor axis of 14. Okay, well, if my vertices are at 10 and -10, remember where your vertices are always located with an ellipse. They're always located on the major axis. And so in this case, my major axis has a length of 20. The radius would be 10, and it's on the y, so this is 10 squared. Which means my minor axis has to be the 14. That has to be the x piece. And if the entire minor axis is 14, it means each radius would have to be 7. And so my x radius in this case would be 7. And then you could clean this equation up. Instead of writing x minus 0, you could write x squared. Instead of 7 squared, you could say 49. Same thing over here. Instead of y minus 0, you could just say y, and then squared. 10 squared is 100, and you'd have your answer. Okay? Number 7, we have vertices, -4, 2, 14, 2, and the length of minor axis is 10. Okay, so again, nice thing about an ellipse, doesn't matter who comes first, x or y. So let me set this up. Okay, and so then if I were to take a moment and to graph the information that I've given, I again have vertices at -4, 2, and 14, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 2. And so my center in this particular case, halfway between -4 and 14, would be at 5. 5, 2, I should say. So 5, 2. That's my x radius, so my entire major axis is 18. My x radius then is 9. And then my y radius, well, if that's my major axis, because that's what connects my vertices here, my minor axis has to be the y-axis, which is a radius of, or sorry, a minor axis of 10, which means it would be a radius of 5. And then again, you could rewrite this, x minus 5 squared, instead of 9 squared, you'd have 81. And then instead of 5 squared, you'd have 25. Okay, and then sliding up, last but not least, we have our hyperbolas. So hyperbolas, we've got their 2 equations here. And now hyperbolas have 2 additional pieces of information that sometimes come into play, as opposed to ellipses, which just have that like big R squared minus little r squared equals c squared. Hyperbolas have c squared equals delta x squared plus delta y squared, as well as their asymptote equation. And both of these equations give you different pieces of information. So if we are told something about our asymptotes, we can see stuff about our h, our k, and then a relationship between our delta y and delta x. If we're given something about our foci, we can use this equation to help us figure out a missing delta potentially. Okay? And so number 8, go ahead and pause this one, give it a shot on your own. Okay, so hyperbolas, it does matter who comes first, so we do need to take a moment and figure that out. But let me go ahead and set up our equation here. Okay, and so if I were to graph this, we have vertices at 0, 6 and 0, negative 6. And the vertices of a hyperbola are those tippy points of your curve. And so in this case, this tells me that my hyperbola, because it goes up and down, has to be y first. And then your center halfway in between would be at 0, 0. That 0, 0 is confirmed by my asymptote, which tells me that my y minus k, k would be 0, x minus h would be 0. Okay. Delta y then in this particular case is 6 out from the center to each vertice, so my delta y is 6. And then my delta x, well, I'm not given any other information except for my asymptote, so somehow I have to be able to get it from my asymptote. We'll take a look at your asymptote equation here. Right here, we know something about our delta y and delta x. Whatever that piece is that's out front of my x represents the slope, and in this case, what's out front of the x is 1. Meaning whatever delta x and delta y are, they need to be able to simplify delta y over delta x to equal 1. Well, since delta y is 6, if I put 6 in here, delta x would also have to be 6. 6 over 6 then would give me the 1 that I've got in my asymptote. And then that's my equation. Okay, last but not least, number 9. Okay, number 9, we've got our vertices at 4 and negative 4, 0. And we've got foci out here at 17 halves and negative 17 halves. Here and 5, 6, 7, 8, 9 here. So again, to connect to the vertex and hold that foci, we'd be looking at a hyperbola that looks something like that. And so this tells me that I am an x-oriented hyperbola. So x first. In this case, my center halfway between my vertices is at 0, 0. My x radius from my center to each vertice is a radius of 4. And then in this case, the only other piece of information we've got is our foci. Our foci are at 17 halves and negative 17 halves. So that's where this equation comes in, because that's what C represents. Your foci. So in this case, my foci are at 17 halves. So it'd be 17 halves squared equals my delta x squared, which is 4 squared, plus my delta y squared. Okay? Well, this 17 is 17 squared is 289, 2 squared is 4, 4 squared is 16. And if I subtract that 16, or aka subtract that 64 over 4, we get 225 over 4, which is my delta y squared. And so this is 225 over 4. And then again, there are things you can do. You could rewrite 4 squared as 16, get rid of the minus zeros. You could pull this 4 up. Because remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So in its kind of most manipulated form, I guess I shouldn't say most manipulated, but in a fairly manipulated form, we'd be looking at something kind of along these lines. If you did all of that, rewriting as 16, getting rid of the minus zeros, doing the reciprocal of this fraction, 4 over 225, that kind of thing. Okay? And that's writing equations.